Now it is time to listen to another financial customer story. Let me introduce you to Eero, who is solution architect at Finnish Asiakastieto.
Hello everyone and welcome to the presentation. My name is Eero and the topic today will be rethinking the development, build and deployment pipeline for the cloud-native world. So what is this really about and why should you care? Well, let's start with a statement of fact. Production workloads are moving into the cloud because of reasons of cost, scale and availability. And there's no reasons why we can't get the same benefits for parts of the development process, including local development, CI/CD, test automation, monitoring, etc. Now, instead of a 3-hour slot, all I was given was a measly 25 minutes, so I had to be picky. And what I'll be presenting today is local development and CI/CD. A brief introduction before we get going. My name is Eero Arvonen and I am a solution architect. I work with the Nordic company and credit information company Suomen Asiakastieto, which is a part of the Enento group. Our local brand in Sweden is UC, and in Norway and Denmark we are known as Prof. Part of what I do is I work in software projects. Typically what I do is I design the microservice architecture for a new service and also work to implement it as well. Another part of what I do is I generally work to improve our processes here, such as practices with OpenShift and CI/CD. Let's start by setting the stage. Within the last couple of years, our company went through some mergers and acquisitions. And as a result, we identified the need to consolidate our IT processes. We call this project Blaze. And Blaze contains 2 tracks. The first one is processes. It has to do with how we build our agile teams and what sort of methodologies we're using. The second one is called platform, and that's the one I'm leading. It contains the technical solutions to facilitate empowering the teams and, improving stuff. Well, I bet none of y'all turned up for a slide fest, so let's go over to the demo, and we're gonna start off with local development environments. Now, the issue with local development environments is that between Finland, Sweden and Norway, there's different hardware, different permissions, different everything regarding workstations. Now, mankind has solved this problem somewhat with solutions like development environments running within virtual machines. In Blaze, however, we wanted to provide the option to move the local development environment even further away from the hardware that the developer has access to. And so we implemented code-ready workspaces. Let's take a typical scenario as an example. Now, I'm sure everyone agrees on the pain that onboarding a new developer to a project contains. Part of it is introducing the new person to the business logic of the application, sure, but there's also the issue that oftentimes the developer is not familiar with the technology used in the project. So let's see how we would go on about onboarding a new developer. Our demo project is an actual project called NUX, short for New User Experience. Now, in Git, we have the link to our code-ready workspaces, so let's go ahead and click that. Next, we add a new workspace by clicking this button right here. And we're going to go ahead and select NUX from the predefined templates list. Then we're going to scroll down over here and click Create and Open. It's going to take a moment for the new workspace to load up, so let's take a break and wait for that to happen. And now we see that our workspace is ready. So let's start off by cloning our Git repository. Okay, there we go. And let's check out a new branch while we're at it. And now we start up the development environment by simply executing one of the predefined commands. Now, being a Node.js application, it's going to download half the internet, so we're going to wait for that to finish here. Alright, so Code-Ready Workspaces is now telling us there's a server listening. We can now navigate to the application by clicking this link right here. Now, this application does some extra work on the first page load, so while that's happening, we're going to open a new file. We're going to have the fresh developer make a concrete change here, so I've opened the index file of the application. And now it looks like the application is properly serving requests. So let's go ahead and make a change in the editor. Hello forum. Save the file. There we go. And now we can see that the change has been hot deployed on the development server. Having made this super useful change, we're obviously going to want to commit it, right? So we're going to navigate here, include the change we just made in the commit, and then add a commit message. We're gonna commit it here. And push it into our Git. Now let's navigate back to the Git and make a merge request. We have our new commit here. Click Create Merge Request. Now we're going to warn our developer friends not to actually merge this, so I'm going to go ahead and write do not merge here. And now we're going to scroll down and submit the merge request. Let's go ahead and navigate to the merge requests tab here. Here we can see our merge request 93, and there's also a little yellow icon here signifying that there's actually a pipeline that's running. And the pipeline is external, so let's check it out. We are now on the OpenShift dashboard, and if we click on this pipeline run over here, it'll take us to the logs and see how our build is doing. This is Tekton doing its thing. So we're going to go ahead and wait for the build to finish here. All right, the build is now done. And what happened here is that based on the merge branch, a new environment was created. So we'll be able to test these specific changes before committing them to the common branch. So let's navigate to the correct project here. Our merge request was number 89, so let's go ahead and open that environment. And here we can see that our change has in fact been deployed to the environment that is based on our merge request. Now there's an additional cool part about Tekton that I'm going to want to show you guys. There's a concept in Tekton called task. Now, a task is something that executes independently in its own pod. A build consists of a set of tasks, and tasks can be shared between projects. What we have here are our cluster tasks. So, for instance, there are tasks here called Docker build, push, deploy, and that's what it does, right? It builds the image, pushes the image, and deploys the image. So, for instance, here there's a task called Docker build, push, deploy, and that's what it does, right? Builder will build it, it'll be pushed into the registry, and then deployed. Currently, we're using these cluster tasks in all of our builds. It doesn't matter if it's, React, Node.js like Nux here, or good old Spring Boot. The application-specific part is the Docker file in the application Git repository that produces the container image. Right. So now if I were to approve the merge request, the code would be merged into the trunk and the changes would be deployed into an environment we call dev. And how do these deployments happen? Well, as a final thing, I'd like to show you how we've implemented continuous deployment with Argo CD. And what is Argo CD? Well, the concept is very simple. Argo CD watches a Git repository and pushes the YAMLs it finds into a Kubernetes cluster. So since we have our local development environments as code and our pipelines as code, why not have our deployments as code as well? This is our apps config repo. Through this, Argo CD keeps track of all the applications it needs to manage. So let's navigate to the Nux application. So when we approve the merge request, after the build is done, some YAMLs will be generated based on Helm charts that will be pushed into this directory. So here we have stuff like, for instance, service accounts, services, and deployments, etc. Once the deployment YAMLs find their way here, they will be picked up by Argo CD and pushed into our OpenShift cluster. Argo CD has its own resource definition called application, and that is what we'll need. Okay, here it is. Here we are saying, okay, there needs to be an environment in the OpenShift project, and the environment YAMLs will be found in this Git repository under this path. After that, Argo CD knows to keep the Nux dev namespace synchronized with this directory. So let's take a concrete look at Argo CD. Okay, so this is the Argo CD dashboard. Mind you, the developer doesn't need to visit the dashboard, so this is not yet another tool the developer has to learn. Here are all the applications Argo CD has found in the apps config repo. If we select the Nux PR application here, we can see that it's managing environments for several pull requests here. There's services in here, there's service accounts in here, deployments, secrets, etc. I think that concludes our demo here, so let's go back to the slides for a minute. All right, let's summarize what we just witnessed here. First off, the work we've done here is about automation. You shouldn't have to learn every tech you're using if you don't want to. We don't all have to be competent with CI/CD, for instance. Automation enables scale. Teams can achieve more with less effort. Third, modularity. These tools aren't, married with 2 kids and a mortgage. More like casually dating. Want to use your favorite IDE? No problem. Tekton is working for you? It's okay. Use GitLab CI/CD, Jenkins, or whichever other tool you want. Already hate Argo CD? Well, okay. You can deploy manually or write a script. At the end of the day, all you have to do is get your code in the Git, your container image into the repository, and then have OpenShift deploy it. As a result of modularity, these tools are migration friendly. You don't have to do a big bang type of migration where you replace the whole toolchain in one go. Okay, so realistically, I do have to take a step back from all that modularity hype. Now, the reality is we actually do need a somewhat defined tool set to be able to enforce stuff like code quality, security, etc. We can't let people do whatever. Still though, the point remains that we, as an organization, have the ability to change one or more of these tools without breaking the whole chain. Also, as a sort of a broader philosophy, we've had 2 tenets. First, everything as code. With the setup we currently have, the whole internal state of the OpenShift, including applications, secrets, routes, and whatnot, exists as code outside of OpenShift. This means we can rebuild the whole thing from scratch without that much effort. And really, everything as code is what really enables the automation and scale I was talking about earlier. Second, SSO. Now, this is something you either did or didn't notice during my presentation. All the tools we have utilize single sign-on. Now, it's kind of a small thing, but it really is convenient because you don't require multiple sets of credentials, and we can keep our access management centralized. Also, I wanted to take the time for a quick shout out to our friends at Stackator. They've been helping us out a lot with Blaze. The only reason I'm able to share all this cool stuff with you is because they've been working with us on it. So thanks Rashid, Amir, and everyone else at Stackator. And with that, we're going to wrap up here. I hope you got some ideas to walk away with. And if you want to get in touch about anything, I'll be happy to talk. Bye bye.